All right, folks, we're going to do some notes on the new section 10.1, Introduction to Logarithmic Functions. One of the things that we're going to talk about here is up to this point, we don't know how to solve equations where the variable is in the exponent. Okay, so if you look at something like this, y equals b to the x, okay, right now we have no, so we're looking at this one right here. Okay, right now we don't have a way to get the x out of the exponent. Okay, so the way that we have to do that is by rewriting something in what's called logarithmic form or log form. Okay, and log form is basically a way for me to take something that's in this exponential form, y equals b to the x, and rewrite it so that I can solve for the exponent x. All right, so what they're saying here is that I can rewrite y equals b to the x to log base b of y and set that equal to x. And again, the main purpose of doing this is to solve for x, to rearrange the equation so that I get x by itself. And we'll get to problems where we solve these here in a little bit. All we're going to focus on today is you being able to go forth from what's called exponential form. So this is what we call exponent, okay, exponential form. And today is going to be a focus on changing it into what's called logarithmic form or just log form. Okay, and we'll spend the majority of today just looking at that. All right, now there are some distinct components that we need to look at here and be familiar with in order to be able to solve this here. All right, we need to look at some of the comparable things here, like the b represents the base. Okay, x in this case represents the exponent. Okay, and the y value is what we're solving for here. Okay, so this is the value that's by itself. Okay, now look at where each of these things are in log form. Okay, you'll notice that the base here is a little subscript. It's not being multiplied. You'll understand. You'll talk about what that little subscript means here in a second. But this is the base. Okay, this is the exponent. Okay, and then this is the value that was originally by itself there, y. Okay. All right, so if we're looking at taking something that's in log form here, okay, you'll notice that if we're looking at log base 2 of 8 equals 3, okay, basically what this is saying here is, okay, the base raised to what power, what exponent, remember because this is the exponent in log form, will give me 8. Okay, so look at where everything is in log form. Okay, look at where everything is in exponential form. So what we're saying here is base 2 raised to the exponent 3 is equal to 8. Okay, again, this is log form. This is exponential form or exponent form. Okay, the key thing here is just noting where things are in log form and comparing them to where they are in exponential form. All right, we'll do the same thing on letter B here. I know this is going to take a minute or two to wrap your head around. So again, just hang with me here, bear with me, and we'll get it figured out here soon enough. All right. So again, okay, this is my base. Okay, this is my exponent. Okay, remember that in log form, the exponent is always by itself. All right, so we're taking base 4 raised to the exponent 0, and that's equal to 1. And we know that that's true, right? Anything raised to the 0 power is going to be 1. Okay. All right, same thing here, only now we have a fraction. Again, we're just looking at where things are in log form. Again, in log form, the exponent's by itself. Okay, the base here is going to be, okay, the little subscript there. Again, we're not multiplying 5 times 1 over 25. We're not adding. Okay, this is kind of like a special form, okay, where I'm looking at this little subscript as being my base. Okay, so the base here is going to be 5 in exponential form. Again, we're changing these into exponential form. Okay, raised to the exponent -2, and that's going to be equal to what's left here, which is 1 over 25. And again, again, we're not solving for anything here. We're just rearranging things from log form into exponential form or exponent form. All right. Now, these next ones here, we're doing the reverse, right? So this is in exponential form, and now we're going back into log form. All right. So again, if we notice where things are here, again, this is going to be my b, my base. Okay, this is my exponent. Okay, which means in log form, exponents are always by themselves. Okay, and then this is the value that we're going to be taking the log of. Okay, so when I write this, okay, it's going to be in log form, which means I need a log. My base here is 12. Okay, it's a little subscript. Okay, I'm taking the log of 12, and that's equal to the exponent. The exponent goes on this side, which would be 1. Okay, again, basically the question that I'm asking when I put this in log form is base 12 to what power, or exponent, to what exponent gives me the number on this side. Okay. All right, so this would be log base 12 of 12 is equal to 1. Same thing here. Okay, this is my base. Okay, this is my power, my exponent. Okay, this is the number we're taking the log of. All right, so what we're doing here is we're going to change this into log form. So log base 7, little subscript 7. Okay, log of 2401, and that's going to be equal to 7. Remember, the exponent is always by itself, or the power of the exponent is always by itself in log form. Okay. All right, last one here. And again, we're just recognizing base, and then this is the power, or exponent, and this is the one that I'm taking the log of. All right, so we rewrite that. Okay, we're looking at log base 1/4. That's a little subscript. The log of 4. Okay, and then in log form, the power or the exponent is always by itself, equals -1. Again, the idea here is we're asking logs ask the question, the base to what power give me the number that I'm trying to take the log of. Okay, you'll see why this is helpful here when we start trying to solve for these here. All right, some special log values here. Anytime that I take the logarithm of 1, it's always going to be equal to 0 because anything raised to the 0 power is equal to 1. Okay. Anytime you have log base b of b, okay, that's always going to be equal to 1 because, remember, we're asking the question, the base to what power gives me b. We're saying b to the x is equal to b, and that's just going to be equal to 1, right? So x would have to be equal to 1 there. Okay. Now, we're also going to be talking about some special logarithms. Special logarithms are just ones that have special bases. Okay, so anytime that you see log base 10, that's what we call the common logarithm or the common log. And what you can assume if you don't see a little subscript there, if you don't see a base there, is it's understood to be a 10. Okay, so log base 10 of x is the same thing as log base log of x. If you don't see the subscript there, it's understood to be a 10. Okay. Now, the second thing you're going to see here is what's known as the natural logarithm or the natural log. And that just means if you have a log base e. Okay, remember e is that number that's something close to 2.718. If you, that's what's known as the natural log. So if you see ln, okay, that just means log base e. Okay, so if it's helpful for you to replace those at any point, if you see natural log and change it into log base E, that's a perfectly acceptable thing to do. Okay, as you're getting started with this and kind of wrapping your brain around these, just make sure that might be a helpful thing to do. All right. All right, so another helpful thing to do here is just to make sure that you're familiar with your calculator. Okay, again, people have different calculators, so you are responsible for making sure you know how to do it on your calculator. Okay, but when I'm doing log 8, again, that's the common log because you don't see the base there. So if you find your calculator, okay, log is on my calculator. I have a TI-30X here. If you hit if you hit the log button, it's the one right below the second button. Okay, if you hit log of 8, I'm going to put 8 in parentheses there so that we don't make any mistakes. Okay, that is going to be 0.903. Okay, 0.90308. Okay, again, if it doesn't tell you how many decimal places, I usually like 2 or 3 decimal places, but you can kind of do what makes sense there. All right, natural log. Okay, is going to be the second button below the second key up in the top left-hand corner there. So all I have to do is hit the LN button of 0.3. Make sure you put 0.3 in parentheses, and that is going to be negative 1.204. Negative 1.20. Actually, it's 39, but we'll round it to 204. Okay. So again, just make sure you know where the log and the natural log buttons are on your calculator because those will be important ones to do here. Okay, an important formula for us to look at here is going to be what's known as the change of base formula, okay, which just means that if you have log base C of A, okay, I can solve this by doing log of A divided by log of C. Remember on these ones here that when you do log of A, it's going to assume base 10. Okay, so what they're saying there is that log base C of A is the same thing as log base 10 of A divided by log base 10 of C. Okay, so I think this is fairly straightforward if we do a couple examples here. So again, you'll need your calculator here, okay, but when we have log base 4 of 64, we can take log of 64 divided by the log of the base 4. All right, and if you do that on your calculator, it's really important to do parentheses here, log of 64, parentheses divided by log of 4, parentheses, and that should be 3. Now, one of the things that I want to mention here is that why this makes sense. Basically, we're asking the question here, what number, or 4, raised to what number gives me 64? Again, this is just exponential form here, right? Okay, 4 to what power gives me 64? Well, we could do guess and check and realize that 4 to the third power gives me 64, and that's why this works here, okay? All right, so the answer there is 3. All right, same thing with the second one. We can do log of 0.2 divided by the log of 5. Okay, that's just a formula here that works to help us solve for logs here. So log of 0.2, make sure you put parentheses in there, log divided by the log of 5, and we get negative 1. And again, the question here is 5 raised to what power gives me 0.2, right? Okay, one of the things that we know is that 0.2 is actually the same thing as 1/5. Right, so it's just a 5 on the bottom. Okay, or this would be, if we were to think about this here, 1/5 is the same thing as 5 to the negative 1, right? Okay, so that makes sense in the sense that what power do I have to raise 5 to get 5 to the negative 1? Well, then x would just have to be negative 1. Okay, but you can do it on your calculator. That's perfectly acceptable here too. All right, same thing on the next one. We're just going right through log of 125 divided by log of 1/5. Just remember, it's the log of the big number over the log of the subscript of the base there. Okay, and again, we're just using our calculator here. The biggest mistake that I see people make is just forgetting to put parentheses in here. So just make sure that you're familiar with how to put parentheses in here. Log of 125 And we get, I'll try that one more time here. I punched the wrong thing in here. I'd put 1 divided by 5. Okay, let's try that one more time. And that should be -3 on your calculator. Okay, if we wanted to work this out by hand to see why this works, again, basically this asks the question, okay, base 1/5 to the what power gives me 125. Okay, I think the easiest way to look at this one is just say, okay, one of the things we can say about 125 is that 125 is 5 to the 3rd power. Okay, one of the things that we know about 1/5 is that it's 5 to the -1, so this is 5 to the -1 to the x. That'd be the same thing as 5 to the -1x equals 5 to the -3, or excuse me, 5 to the 3. And if -1x equals 3, okay, then x has to be equal to 3. All right, last one here. Okay, base 36, or log base 36 equals 6, so I can do log of 6 divided by the log of 36. And again, we're just punching this in on our calculator. Okay, so log of 6 divided by the log of 36, and I get 0.5. Okay, again, if you're interested on knowing why this works, okay, we're basically asking the question 36 to what power gives me 6. Okay, one of the things that we can say is that 36 is 6 squared, all right? Okay, to the 1st, right? So if the bases are the same there, then I could say that 2x is equal to 1. All right, if 2x is equal to 1, then x is equal to 0.5. So again, mostly I'm just making sure that we know how to use our calculators, but I think it's also helpful to know kind of why this works here. All right, the last thing that we are doing here is we are finding inverse functions. Like this video is already pretty long here, so we'll pick a couple of these to do. All right, remember that when we find inverses, okay, one of the things that we have to do is we switch x and y, and then we solve for y. Okay, so one of the things that we'll do here is when we're, one of these things that we'll see, again, we did this back a month or two back now, when we find the inverse of something like x to the 3rd minus 4, okay, the idea is we switch the x and the y, okay, so the x and the y get switched, and then we get x equals y to the 3rd minus 4, okay, and then we just solve for y. So we add 4 to both sides, okay, so we get x plus 4 equals y to the 3rd, and then I just get the y by itself by taking the 3rd root of both sides. So I get the 3rd root of x plus 4, okay, equals y, because the 3rd root of y to the 3rd, remember that a 3rd root and a 3rd power cancel each other out, so that's just a y. And I get the 3rd root of x plus 4. Okay, well, it's the same deal here. Okay, you're swapping the x and the y and then just solving for y. Okay, so the first thing we'll do here is just switch these two, and I'll get x equals log base 4 of y. Okay. Okay, so the way that we're going to solve this is to put it into exponential form. Okay, remember what we see in log form, the exponent is always by itself. Okay, this is the base. Okay, and then in exponential form, the y value will be by itself. So we'll end up getting, okay, base 4 raised to the power x is equal to y. Okay, and all we had to do in this one was swap x and y and then change it from log form into exponential form. Remember, all we did here, again, was the thing we did all the way back at the beginning. Okay, and this is log form. This is exponential form. Okay. All right, let's take a look at letter B here. Okay, first thing we're going to do is swap x and y. Okay, so we'll end up with x equals 2 log base 3 of now y minus 5. Okay, so the first thing we're going to do is change this from log form into exponential form. One of the things we have to do first, okay, is we have to so we're just going to change this into exponential form. Okay, remember that this right here is the base. I'm looking at this here. I think this 2 was a typo. Yeah, so the 2 is a typo for right now. We're going to get rid of that for just a second because I don't think we're going to need that. Yeah, I don't want the 2 here. All right, so we're going to go back for a second. This is going to be, we're going to cross off the 2 here. Okay, so we're swapping the x and the y. We'll deal with something like that a little bit later down the road. All right, so what we're looking at here is this is my base. This is my, remember in log form, the exponent is by itself. Okay, so, and then this is the value that'll be by itself in exponential form. Okay, the y minus 5. All right, so we've got 3 raised to the x power, okay, is going to be equal to y minus 5. Okay, again, all we're doing here is getting the y by itself, so we're going to add 5 to both sides, and we get y equals 3 to the x plus 5. You'll notice that the plus 5 is not up in the exponent, and we have something like that. All right, let's skip down here just a little bit because this is going to be a long video, and that's okay, but I just want us to see some of these different ones here. All right, let's take a look at, I do want to do letter F here. I think letter F will be the last one we do here. Okay. So now we've got y equals 3 times the log base 7 of 2x plus 1. First thing we're going to do is swap the x and the y. Okay, so we're going to end up with x equals 3 log base 7 of 2y plus 1. Okay, and now what we need to do is, before we can change this into exponential form, what I'm going to do is I'm going to divide everything by 3, because I can't change this into exponential form without the log being by itself. Okay, so what we're going to do is we're going to get rid of the 3's here. Okay, 3's cancel out on this side. I get x over 3, x divided by 3, equal to log base 7 of 2y plus 1. Okay, now what we can do is change this into exponential form, where this is my base, and remember in exponential or in log form, this right here is the whole thing here is going to be the exponent. All right, and then what we'll do, and again the 2y minus plus 1 will be the value by itself, so I'll have 7 raised to the x divided by 3 is equal to 2y plus 1. Okay, and then what we'll do is just work on getting the y by itself. Okay, so I got to subtract 1 and subtract 1. Okay, so we'll end up with a 7 to the x divided by 3. That's all up in the exponent, minus 1. Okay, equals 2 times y. And then all I have to do there is divide everything by 2. Divide everything by 2. And I'm just going to leave it like that, I think. So the y's cancel out here, and I get y equals 7 raised to the x divided by 3 minus 1. Again, that minus 1 is not in the exponent, all divided by 2. Okay, and that's all we're going to do there. All right, folks, that's it for your notes. If you have questions on any of this stuff, I know that changing things from log form into exponential form can be a little bit to wrap your brain around, so please ask for help if you have questions. But otherwise, I'm going to stop there. Okay, the rest of the time is going to be yours to do homework. Let me know if you need anything. We're going to take some time to make sure that we understand log form to exponential form and vice versa. So again, please advocate for yourself if you have questions, but otherwise, time is yours. Let me know if there's anything you need. Thanks, folks.